Jesus, what? This is ridiculous. Oh, 0. Ah, god damn it. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays. Okay. In your submarine are malfunctioning. 7-segment displays. So those are the clocks, right? Yes, they are. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of a 7-segment display is read by turning on and off any of the 7 segments, name it A through G, okay? 0, 1, 2, 3, 4, 5. This is really cool. So to render 1, only segment C and F should be turned on. The rest would be off. To render a 7, only... Okay. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires, A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All the digits within a display use the same connection flow. What a second, I'm confused. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing are mixed up separately for each 4-digit display. What do they mean by 4-digit display here? Oh, okay, thank you very much. Each 4-digit display means each line in the puzzle input. Took more time for me to read and understand this puzzle than solve it. Okay, so you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are on. With just this information, you can still tell which wire B and G goes to each segment C and F. For that, you need to collect more information. So it's kind of a puzzle thing. For each display, you watch the change in signal for a while, make a note of all the unique signal patterns you see, and then you write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to each digit. For example, here's what I might say in a single entry in your notes. Wait, is this... Okay, it's just... What is this? Is this a... The entry is wrapped here to 2 lines, so it fits in your notes. It will all be in a single line. Okay. Each entry consists of 10 unique signal patterns, this delimiter, and finally the 4-digit output value. Within an entry, the same wire segment connections are used, but you don't know what the connections are actually. The unique signal patterns correspond, okay, because 7 is the only digit that is used to this, okay. Alright, you should be able to work out which combination of signal wires correspond to each 10 digits. Then you can decode your 4-digit output value. Unfortunately, in the example above, all the digits in the output value use 5 segments and are... For now, focus on these digits. Consider this larger example. Because the digits 1, 4, 7, 8 each use unique combination, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output value, the part on each line, the example above, there are 26 instances of digits that use unique number of segments, highlighted above. Oh wow, this is a lot, indeed. I don't think I can go forward without reading again, or reading a good amount again. Alright, let's get started. So let's get the input. I'm just thinking how we're going to do this. I'm just going to break on everything and then add a chunk. So we're going to have the input. So we are going to split on those 2 things. So you can see that we get everything, but we want to do a num chunk every 2. Okay, so we have the input and we have the output. Oh, there's a trim in there, as one usually has. And those are our in-outs, right? It's the inputs and the outputs. I'm just going to call it inputs. We can break this a little bit further apart. Let's map this a little bit more. And we are going to have the input, we are going to have the output. Let's call this parsed. It's really what it is. And we want to say, look, we want to split the input and we want to split the output. Okay, what? Yeah, okay, this is good. So we have those things. We don't need to check the inputs, we just need to check the outputs, I think. Is this correct? CG. Yeah, this is correct. We just look at the outputs. Can we do a count with, no, it's not a count, it's a sum. All right, let's just go through the parse ones. There is the input that we know we don't care about. there is the output. Yeah, so part one is, if this is correct, it's going to be, so we want to count, let's do the byte size of the output. We want to get the byte size. It can be string length, but because it's ASCII, byte size and string length is going to be the same thing. I'm going to use string length. There's this conflict in the person who wants to optimize and the person who wants to be correct. It doesn't matter. Those are the counts. And then what we want to do, no, those are the sizes. We want to count all the sizes that are in 2. So 2, 7, 3, and 4. Is that it? Yes. 2, 7, 3, and 4. I can just do this in one pass. So we want to count all where the byte size is in one of those. And this is going to give us the sum. So we go back here and 26. String length is not the same as string graphemes input. It's optimized because we don't need to build the intermediate graphemes, but it's linear. So it's the same algorithm complexity. So this is good. So far, easy. Let's do the usual setup. So setup here, I'm going to do a mix install of, as usual, Kino. We want 0.41. And we are going to do an input in here. So input equals Kino input text area. Please. All right, let's put this here. And this is going to be Kino input read. Should be the same thing. We still got 26. When is better to use string length? It's easier to ask, when do you want to use byte size? You use byte size when you're working with binaries, so you know everything's like a blob, or you know that everything is ASCII, right? Other than that, it's going to be wrong. So byte size of my name is going to be wrong. Read the docs in the string module. They are really put a lot of effort into them, and I'm hoping they are going to explain the concepts really, really well. And I'm telling you to read the docs, not because like, hey, read the docs, right? You know, rather that we put a lot of love into them, so you know, they're going to answer those questions, and possibly in a better way that I can do right now, because there's a lot of effort in there. All right, so let's get my input. And okay, they told us that. You know what? We're just going to do this. We're going to add something else to split on, and we're going to be good on both cases. And 404. Part 2, who is ready? Who is ready? From a little deduction should now be able to determine the remaining digits. Consider again the first example above, right? After some careful analysis, the mapping between signals, wires, and segments only makes sense in the following configuration. All right, so you know what I'm going to do? I'm going to first write the algorithm to solve this line and in isolation, and then we try to put everything together after some careful analysis, right? Yes, it does tell you it's a careful analysis. So my understanding is that we'll have to look at those things and come up with the rules, right? So we know, please let me know if I'm wrong. I think there's a given order we can process things that is going to give us the result. There is no brute force. We just need to look at those things, think hard about them, and say, hey, after I look at this, I can look at this, and if you can solve one line, I can solve all lines, right? So I'm going to start with 1, which is the obvious one. What are the special inputs? It's 1, 4, 7, and 8. Is that it? Those are the special ones, right? Yeah, so looking at 1 or 7 or 4, we can already figure a lot out. We can know which one is CF, right? Wait, no, we cannot know. We cannot, wait, not necessarily, right? Because the order can be any. I can see the differences, right? I can know what is A. If I look at 7 and I look at 1, I know which one is A. And that is going to help us solve a bunch of stuff. But it doesn't tell me which one is C and which one is F. I can only know which one is C and which one is F with 5 or 6, right? That's how it works. All right, we can do this. So I'm going to get this. All right, and we want to convert each of those to, there is no chance we get duplicates in here because here should be all digits in a random order, but there are no duplicates. Okay, good. Knowing A is kind of useless. It's a good start for reasoning. We want to know which one is 7. That's what we want to do. You are right. Knowing which one is A is useless, but I want to know which one is 7. You're correct. We need to do 2 things, right? So we need to work with characters. Let's get this input, and what I want to do is that I'm going to do a string split on it. And then I want a map to give me char lists, because then we can work with them as list of characters. What we can do is that we can find some of them, right? So we know that the 7 is going to be, of those inputs, we want to find the one where the length is, come on, where the length is 3. That's going to give us the 7. The 1 is the one where the length is 2. 4 is the one the length is 4. Is this correct? 4, the length is 4, and 8 is the length is 1, 2, 3, 4, 5, 6, 7. 7. Okay. This is the 4, and this is 8. What did I do wrong? Oh, okay. So we have, wait, do we need to, okay, we don't know which one is 0. We know which one is 1. We don't know which one is 2. We don't know which one is 3. We know which one is 4. We don't know 5. We don't know 6. We know 7. And we know 8. And we don't know 9. So far, so good? So far, so good. All right, so how can we... All right, so now it's looking at this and trying to figure out the equation. So 1 minus the other should tell me... Okay, 0 is going to be, okay, let's say this correct. 0 is going to be, no, we can't say anything with 0. We don't know the difference between 0 and 9. We do know, however, 9 and 4, there is something close here. There's a lot of similarities here. Oh, is the only one that has 4 similar characters as 4 as 9. So if there is something that has all the characters that 4 has, it has to be 9. Or 8, but we already took 8 out, right? So that's how we're going to get 9, I believe. So 9 is going to be, we are going to get, of the input, we are going to get 4 minus the input. And if this is an empty list, if we get 4, we take everything, right? We want a filter, and then we take out 8. That should be 9. Okay, so we get 4. This precedence here is killing me. Let me write the whole thing. Minus 8, that should be 9. Okay, you can see that that worked pretty bad. Why? Do we have overlap anywhere else? It's only 8. Filter on length. I'm not thinking I was supposed to filter on the length. The only numbers that can take everything from 4 is 9, 8, and that's it, right? We don't have any other. Right, but that's the part that I don't understand. Like, according to my understanding of this... Oh, we need to take 4 itself out, right? Oh, 8 is not being removed. Oh, of course. Yes. Okay. All right. So we need to take 8 and 4 out. That should give us just a single number. Okay. Yes. Thank you. Yes. So we take 8 and 4 out. If we use this formula again, we can try to encapsulate it. We can encapsulate into smaller functions. All right, so what other property we can find? From 9, 8 is easy, but that's not what we want. 3, can we do 3? Or we did 1, we didn't do 3. Okay, we can get 6 now, right? Because from 8, there are only 2 things that when you take 1 out of each. So 6 and 9, there are 8 missing 1. We already have 9. So the other one's going to be 6. Let's go back there. How we are going to do this? We have 8, and then we want to take the input. Okay, I know a cleaner way of writing this one, which is going to be used for the future too. So we want to do this, and this should match a 1 element empty list. Let's write this other one. 6 is going to be a num filter, and we want to take the input. This is 6, and we want to remove 9. Am I wrong? It's 8. Oh, 0. Ah, god damn it. All right. So this is 6, 0. We don't know which one it is. Maybe this is going to be useful in the future. Also 0. Yes. Thank you very much. What else can we look at? Is there any relationship? 3 and 2, it's a similar thing. 2, 3, and 5 have the same relationship with 8. We need to find another one. Wait. Okay, 7 has something common with 0, but not with 6. Okay, so this is 6 or 0, right? And then we want to say, look, if I take 7 out and there is nothing left, that's 0, right? And the other one has to be 6. Let's do a split with. No, let's go simple because I'm already confused. So 6 or 0, and then we do, I said 4, no, 7. And then if I do the input, no, if I do 7 minus the input. If I do 7 minus the input, so if I do 6 and I have nothing left, that's 0, right? And then by definition, I need to do this. That's going to be 6. So we got this. I don't know if it's correct. All right, so which one is 0? CageDB. Is that a fake advertisement? EAFB is 4. This is good. I think this is solid. I think this is working. Ceph ABD is 9. This is pretty good. This is working. Which ones we have left? It's just 3 left. Okay. Just 2, 3, and 5. Okay. 2, 3, and 5. So I can use the same technique. 3 is going to have something common with 7. So that's the first technique here. So let's get 2 or 3 or 5, right? And that's going to be, what are their lengths? 1, 2, 3, 4, 5. Okay, 5 segments. So maybe we should do a map first to get those things. We'll clean it out later. It's going to be, I think I could do a map and then I just need to access the map and get the things that we want. I think that will be a nice way to clean it up. And then we know that 3 is going to be this. It's the one that I can take, well, there is nothing common with 7. So this is going to be 3. FBCAD. FBCAD. All right, we are good. 3. There are only 2 left. And we need to see what is the technique we can use to find this. There is only 2 and 5. 2 have, oh, 6 and 5. There is only one difference. Is this correct? 6 and 5, there is only one difference. And 2 and 5, there is 2 differences. Okay, so that's it. Wait a second. What was the other one? Was 3. 3 and 6, there is, hold on. Let's go back there. If I try to take everything out of 6, and I have 2 things left, then I have 2. If I try to take everything out of 6 and I have, oh, 0. Ah, god damn it. 5, I think. SDFB. All right, we are good. Whatever is left, it's going to be, how do we get, well, we can get 2 is going to be 2 or 3 or 5 minus 3 or 5 by definition. So this is 2. This is solved. Let's clean this up a little bit before we plug this into the final solution. I want to, or is that going to be a big mistake right here? So I want to do a group by, let's open up another cell so we don't mess this one for now. Yeah, I think that's a good strategy in general. So let's keep this one as is. That's why notebooks are so nice, right? We can come here, we can make a mess. This is our input, and I want to do a group by length. Is this how it works? No, first we need to do an enum map still. Wait, we can pass, hold on. Can I do here? Let's check the docs, right? Why guess, key fun, value fun. So we want the key to be string to char, no, we want the key to be the byte size. And we want the value to be string to char list. Okay, so this is pretty cool. So this is a map. We can do 7 as being map 3. We can do 1 as being map 2. We can do 4 as being map 4. We can do 8 as being map 7. Those are the initial ones. And which one is 9? 9 is the one, how many we have with 6 digits? We have 0, 6, and 9. Is this correct? 6, 0, and 9. Yes. Okay. So we know that 0, 6, 9, this is going to be map 6, correct? And we know that, which one is left? We know that 2, 3, or 5, that's going to be map 5. All good? Let's sort this for, we can do a single beautiful pattern match. Hold on, are you all ready? 1 and 3 and 4. 4 is going to be 4, and then 4, 4, and then we have 5, and we know that 5 is 2, 3, or 5. 6, and then 7 is going to be 8. And this is the map, and now we can take a lot of things out. All right, look at this. 1 pattern match, 1 pipe. That's all you get. You have to solve the problem with 1 pattern match and 1 pipe. We know that 9, this is a fine now, is going to be 069, and it matches the 4. And we know that 6 or 0, let's call, I'll refactor this later. We know that this is going to be then, well, we do have split width. That would work, but I'll do that other refactoring later. We can use split width, I think, but I don't want to rock the boat too much. 6 or 0, let's call this 0, 6, 0, 6, 0, 6. And 2, 3, or 5, we already have this. It's just that, let's call this 2, 3, 5. 2, 3, 5, 2, 3, 5, 2, 3, 5, 2, 3, 5, and does this still work? This still work. Okay, I like this a lot better. I think we are cleaning it up considerably, and there is more we can do. The thing is, what if I don't do this? Is it broken? Why does it work? Wait, yeah, so if I take 9 from 7, let's go back there. I want to see if I'm not accidentally breaking a property. If I take, it takes everything. So if 7 minus 9 takes everything. So, oh, it's just finding the first. This is working by accident. So you know what? In order to make sure that we are not relying on ordering anywhere, we are going to do this. We should do this everywhere, because otherwise we can just be implicitly rely on the ordering. Like, hey, this is the first that matched this pattern. And that would be problematic. 069. Okay, is this still correct key? So this is the other benefit of pattern matching, because with pattern matching, we can write those assertions very cleanly. You can say, look, I want something with this property. And so let's do the same here, right? This should be 3, there should be nothing more. And this is it. I think this is my best offer. I don't think I can beat this. We can refactor this a little bit and put this into a function, but I'm quite happy with how things are. So let's go back here. I think we can discard this one. Let me just check again, just in case, you know, it's a lot of work in here. First time I'm like legit worried about losing the code, because the only way to write this code again is by thinking a lot again. Let's manage with care. So the input here, let's change this input a little bit. And let's do this group by. Ah, this is so ugly. It's fine, we'll survive. So that's the parsed, and this, let's move to a shared section because it's shared between both notebooks. So that's the parsed thing, okay? And now we know that map, wait, I don't even know what we are supposed to solve. Are we supposed to guess all the digits? All right. The output value for this entry is 5353. Oh, we are supposed to get the things. Okay. The order always matches, right? They're not going to swap, because if they're swapping, then that's evil. They are swapping. Okay. They are just... they are... Okay. Okay, so this is... Okay, they are swapping. They are doing that to us. Good to know. So what we can do is that... Should we just do a big map as answer? This is it. We are going to build the numbers. And what do we do at the end? If you add up all the output values. Okay, what happens if we add up all the output values? So we have parsed. For each one, we have the input and the output. This is part of the work in here. So we know that the sorted 0 is going to be 0. I'm so sorry. Maybe there's a cleaner way, but we'll think about cleaner later. 5, 6, 7, 8. Yeah, I'm not checking the chat a lot today. I'm sorry. If there's a cleaner way of doing this is the input. Those are the numbers. 4, 5, 6, 7, 8, 9. I want to convert these to a char list too. So these I want the output to be a char list as well, because that's how we're going to compare them. It's in a map. This is good. And so this should be length. And we know the output is going to be digit D1, D2, D3, D4. All right. And I know that we should have numbers D1, the sort of D1. Jesus, what? Like, there is the sort of D2 multiplied by 100 plus the sort of D3 plus D4. So I think this is it. And now I want a sum. There are definitely other ways we could do this. We could do... I already know another way. I'm going to share soon. And then you let me know which one you prefer. Let's get this. And let's run this. Is this the answer for 1229? It is! I'm sorry. It works! It works! This is ridiculous. It works! Let's try it on the input. Let me try on the input. I'm just thinking about ways to improve that, but we'll do it soon. Yes! This is great. This is great.